My name is Paul Ozinga and I'm one of the speakers today. I will tell you more about the commercial aspects of KNX in the application, and Alan sitting next to me will talk more about the technology behind it. What are we going to talk about? Well, first we have a little bit of an introduction on especially what is KNX. I don't know if the audience is completely knowledgeable about KNX, but I do want to give a small introduction on what it is. I also want to make a little bit of a comparison between the three major open systems that are available in the world at this moment. But also talk a little bit about what is the special role of KNX and Philips, what is the special connection in that. We will show you a little bit of light control techniques. We will do that in the form of a video where we explain how we get savings, because that's an important part, and what we can do more with the light controls. Then we talk about two applications, in this case an office and an industry application. Then Alan will start with the way of working, how does it work, what is now so special about our solution, a little bit about plug-in so that you have a feeling on what it is that we do with KNX, a little bit about the lighting technology, and we'll finish off with the general idea of connected lighting within Philips. So that is the program for this moment. So moving on to the first slide, we first want to talk you over on the KNX standard. KNX is a standard all over the world. And before we dive into what KNX exactly is and what it does, it shows you here why KNX is so powerful. It is all over the world, and it is also in many countries. It is the dominant open protocol systems. As a matter of fact, I dare to say that except for Northern America, KNX is the leader in the whole world for open systems, and you can see they've got all the standards that are required to work in the world to be followed. KNX is known everywhere. And also a very powerful point of KNX is that there are so many manufacturers of products and services. There are more than 300 KNX manufacturers in 35 countries offering more than 7,000 certified KNX devices. And that is an awful lot more than any other open system that is available at the market at this moment. The KNX organization is also massively available in the world, because in more than 120 countries you will find KNX organizations. You will find that there is training available, that there are user clubs, that there are manufacturer clubs, etc., etc. It's all over the world available. Like I said, in more than 120 countries it is available there. And you can see it is widely spread all over the globe. Is now that KNX standard? Well, KNX standard was formed in 1999 and based on three other standards in Europe that were available at that moment. The first one was AIB or Instabus. That was the biggest one at that moment. But another standard was Batenbus and the European Home System. Together they formed Connex, or KNX as it's called now, and in 2002 the KNX standard was ready, and it became a European and international norm shortly after that. But AEB was already introduced far before that, in 1991. It was formed by Berger, Jung, Gira, Merten and Siemens. For those of you who do not know those brands, those companies are specifically working in installation technology. So that means they're talking about switches, about sockets, connections between them. And basically the EIB standard was meant as a soft wiring protocol between the switches and outputs, as they call them, actuators. That is something that you still find back in KNX. That soft wiring idea is still in the system. If you look at the characteristics of KNX, what is it now that we are talking about? Well, first of all, there is a definition of the bus. It can be either a twisted pair, it can be RF, it can be Ethernet, but the bus is defined as such. and the protocol over it as well. And I always compare that that gives you the ability to talk and listen. It does not mean, I think you all know, that if you talk and listen that you will understand each other, but at least you can talk and listen to each other. That understanding comes from the defined interface. That means that basically if there is a message on the KNX bus, that message has been defined. So on both sides they know, okay, this is the message I have to send, and the other side knows how to receive that message and how to understand the message. So now we can talk to each other, and we can understand each other, and we can work together. But KNX has two other big advantages, and the first of all of them is that there is one tool. That means that the system is very effective, because there's only one tool working. Everything is made for that, and at this moment that tool is called ETS in version 4, and version 5 is coming up. Another way of why KNX is very positive is that there is one way of working. That means that it is not only an effective way of working, but it's also a very efficient way. There are quite a lot of installers who are very well trained in KNX and who can work with KNX. And that brings us immediately to the advantages. Because there is one bus, because we talk all the same language, in KNX we can share resources. One of the most obvious of that is that we can use, for instance, one sensor. You'll see in the examples later on, for instance, a movement detector, or a panel, or switches, or whatever, and you can use it for several disciplines. With one motion detector, we can switch the HVAC, the ventilation, the lighting, the sun blinds, etc. So you can share resources, making the total installations a lot cheaper. The same thing applies for if you want to have a SCADA tool or a BMS or whatever. You want to have a screen where you have readout of energy use, for instance. Well, you can do that for all disciplines in one way. So that makes the system much easier and at the end also much cheaper to use. Another big advantage for the end user is the fact that you can change components without affecting the others. Say that there is a company A who makes a certain solution, and there is a company B and C that makes solutions around it. For instance, A from beam lighting and B and C from HVAC and sun blinds. Then it is easy to change one component or one part of the system, for instance the lighting system, without affecting the HVAC or the sun blind system in a building. And that makes it is easier to compete, and a user can easier select the best solution for his or her application. Also, the threshold for new products is lower, since all the elements of how to work with that component are already defined in the KNX system. The tool is defined, the protocol is defined, so you only get a new function. You don't need to worry about the rest. Like I already said, there are many installers, over 14,000 installers at this moment in time, that are trained and experienced in KNX. So here it is also easy to find one. Again, you will find some competition there. There are enough people who are using KNX, and you can use the installer that you like to use there. And then the biggest advantage of KNX is that it is huge. I already told you in the previous slide, there are so many manufacturers that making KNX products, so that if you have a problem, then it's bound to have already got a solution in KNX. And there must be a supplier who can offer you the product or the service that you require. We want to show you the advantages of lighting control systems and the way we achieve energy saving.
Why would you light the whole building at 6 AM when there are only a few people at work? Smart scheduling allows you to switch luminaires to reflect the average daily use. Everybody knows that the simplest way to save energy is to turn off the light when nobody's in the office. By installing sensors, the lighting automatically switches off when there's nobody in the office for a period of time, allowing you to save up to 30% energy. Why do we light an area even when there are only a few people at work? Sensors allow us to dim unoccupied workstations, while maintaining a visual comfort around with minimum energy consumption. Why don't we take advantage of the available daylight? Our sensor measures the amount of light in the room and automatically adjusts the lighting to fully benefit from the sun. Most lamps and luminaires are specified with a safe margin for dust and aging. To ensure the right light level over time, our sensor measures the amount of light in the room and adjusts the output automatically. Most buildings are designed strictly with desk lighting in mind. To eliminate overlighting of walkways or coffee corners, you can reduce the light level in these areas, making your coffee even more enjoyable. As you can see, today's controls allow you to automatically save more than 50% of energy without any loss of comfort. When you're alone in the office, you want to feel safe. But leaving all lights on isn't an option. That's why we dim the lights in corridors and facilitate a comfortable exit by illuminating the way forward. There's no need to open the ceiling and change the wiring of the luminaires when the office layout changes. With a management system, you can simply adjust the settings to the new floor plan. And it allows you to gain clear insight into your savings and progress towards your targets. So, when energy consumption is higher than expected, these insights can help you to respond effectively. The demand for energy in a building varies throughout the day, and peak energy is expensive. To benefit from cheaper energy, you can auto-reduce energy on non-essential lighting to stay within your capacity contract. Connectivity to your future smart grid is also possible.
If you look further, what is the purpose of Philips within the KNX community? Well, we bring a couple of new things. First of all, we bring our lighting limitations to KNX, but we also have a little bit of a different way of working. The first thing that we offer is that we have got a completely pre-programmed lighting controller. Since we know that lighting controls can be quite complex, we basically did all the programming already up front, and with an easy-to-use plugin, basically we only set the parameters for the function that you require. Alan will go into detail on showing you how that is exactly working. But not only that, also we know quite a lot about lighting installation, because we are already doing that for more than 120 years. One of the things that you see here, for instance, is what we call a structured wire solution, and that is basically a controller that we also have been using in other systems with VLAN connectors or with other type of connectors. Connected systems are very popular, especially in Europe, because they reduce the installation time. They also reduce dramatically the chance that you make an installation error. And because we know that, because we deliver our luminaires with that technology, with that connected technology, we also have controllers and other devices that follow that. And since it is not a complete standard, but quite a lot of the manufacturers are using VLAN or other connectors, you can be certain that it can be applied with the luminaires of your choice. Another example of that is the fact that we have got DALI controllers, but also DALI sensors. You will see that later in the presentation, an example where we can take full advantage of that. Using DALI sensors instead of KNX sensors means that you can use cheaper sensors, but you also do not need a KNX line to go to them. There where your luminaires are, you can use the sensors and using one DALI line to connect them all together. What is now the best open system that is available at the moment in the market? Well, I put the three most famous ones that are usually discussed here in a table, and that is KNX, that is LONG, or as the standard is called, the Longmark International, and that is BACnet. Well, if you first look at the most obvious difference between LONG and KNX and BACnet is that both the LONG and KNX are local buses and are capable of doing full control. The BACnet system is too slow for that. You can do it with HVAC, but especially for blinds and for lighting, the system is not fast enough. And therefore also BACnet was designed more or less to be for gateways, for management information, and not so much for the control buses such. If you look at the definition, then the BACnet interface only defines values. It doesn't say anything what it means in value like that. There is an analog value with a digital value and a couple of variants on it. The KNX bus goes further than that. It also defines variables. So it means there is a movement detector, there is a temperature sensor, and then the temperature sensor gives a certain value. The Longmark standard goes the furthest and has got a full definition of variables, values, functions, and applications. So basically, a complete lighting controls application is described in the standard, and how the controller should look like, what type of inputs you should have, what type of outputs, how you should connect them, etc., etc. Another big difference between the systems is the use of the tools. As I already mentioned, KNX has got one tool called ATS. For Longmark, there are a number of tools available, also manufacturer specific. So that means that you have to get used to a different tool if you do different projects. And BACnet does not have a tool at all. You have to set all the variables and addresses manually. Already mentioned 2 times, and this promise is the last time I will do. KNX, there are an awful lot of manufacturers, a lot of users there. If you look at Longmark, Longmark is far more limited to a number of manufacturers. I believe there are 50 active manufacturers at this moment, and also the number of users is far less than for KNX. BACnet is basically supported by basically any system as such. I hope that this overview shows a little bit of what are the advantages and disadvantages of different systems. Like I said before, Philips offers all solutions, so we do not have a real preference for one or another. I do want to point out that KNX is, of course, by far the biggest one of all 3 of them. Okay, I want to go to the first application, and the first application is an office building in France, in Lille, in the north of France. It is basically, we set it up as a test site for light balancing. And that is some technology that we do together with Somfy, and I'll explain it in a second. We do testing about the comfort feeling of the users there, if they like systems like this. It has been realized in 2013, and after the summer holidays we will start with the evaluation of it. It is a very nice example of how integration can get to maximum savings, because in the way we work in this building, we have additional savings in the lighting. We go from 50 to 60%. You already saw a video that we can achieve 50–55%. We can go even further if we work together with the blind system. But also on the HVAC system, there was already a 10% savings possible, and that is especially in the cooling and in the heating. And the nice thing about it is that it is at very little extra cost, because basically you already have systems like this in your building, and KNX gives you the possibility to make them communicate with each other, and makes it possible to work together. Well, here you see an example. I will not go into detail there, but I do want to point out that you see there our DALI controller talking to the lighting. It's using a DALI protocol. It's called Digital Addressable Lighting Interface, and this is basically a digital interface to address lighting instead of relays. We are using a digital protocol. And you also see that we use here a DALI sensor. So the sensor is not connected to the KNX bus, but to the DALI bus. That doesn't matter as such, because if you look from the KNX side, the DALI sensor is completely equal to a KNX sensor. So there is no difference there. On the right hand side, you see the different controllers that are used by our partner in this one, Somfy. And on the bottom, you also see the weather station. And you see the panels that are used there to control as well the blinds as the lighting in the system. How does it now work? Well, basically with the light balancing system, if there is somebody present in the building and there is not too much sun, then the lights will be open. You already see that what we call daylight dependent regulation is working. The luminaires on the window side are dimmed already. You see a person working there. And a nice comfortable temperature, because all the systems are working. There's a little bit more light coming in, and you see that the blinds are pulled down. Sorry, I see on my monitor screen not a second. Oh yes, there it is. Sorry for that. You see that the blinds are pulled down, and the amount of sunlight coming into the room is less than before. You see that because of sunlight there, the luminance on the window side are now completely dimmed and can even be switched off. And a little bit further away from the window, they are still on. If you move on to the last situation, now there is full sun. You see the slides are down completely. They're blocking the amount of sunlight to a maximum. Also to keep the heat out of the room. But still sunlight is coming in, enough to light up the whole area. And all the additional light in there can be switched off, if you can see in the picture. Well, until now it is quite straightforward. You would not expect anything else. But now it gets more interesting, and that's the part when there is nobody in the room anymore. Well, if there's nobody there and the room is heated up, but outside it is cold, we close some lines because we can now retain the heat inside the building. We can also use the sun to heat up the building. If it is inside, it is cold, then we open up the blinds as long as there is nobody in the room, and then the sun will do part of the heating of the room. And here you see that we cooperate within KNX with the blind system, with the lighting system and the HVAC system to get optimal savings. Well, of course you would imagine that it also works the other way around. If it is internally too hot already, and you want to start cooling, you want to close off all the sun from the area and do a minimum of cooling. Well, here you see that this light balancing technique that we can do additional savings up to the individual savings of the different systems. Another example of where we can use this lighting technology and this integration is in a warehouse. We are working on a project at this moment, a distribution center somewhere in Europe. Since it is not finished yet, I'm not allowed to tell you exactly where it is. Sorry for this, but it will be realized this summer. Of course, as you would expect, it is a full LED solution. All lighting is done with LED, but we are adding controls to it to get an additional savings of about 60%. We do that with occupancy control and with daylight dependent regulation, and I'll show you in an example how we do that. First of all, you see here the warehouse. We use trunking, basically a light line system, and we connect to that trunking system our sensors, and they detect a part of an aisle, which you saw in the previous page there. That you see those aisles with the racks where all the goods are stored and where the stock is taken from and to. Well, basically you see also on top of those aisles, you see those light lines, the trunking as we call them, and they are placed there. And we put there the different movements detectors on it, and there we detect in so-called zones. How is it set up? Well, here you basically see a trunking system like that. You see the luminaire, the LED luminaires, and the movement detectors. Of course, well, here you see the components again. You see that in the trunking system there is a cable, a 6 or 5 pole cable that carries all the power. You see the LED luminaire, and you see our sensor connected to it. Well, of course, in the trunking system we have got the power to power up the luminaires, but we are also using again the DALI system to address all the different luminaires and the different systems. And you see that I can do that, all of that without any additional wiring, without doing any additional installation other than for the sensors itself. So what can we do then with that? Well, basically we are dividing up aisles into zones. And the zones are defined corresponding to their use. If you see all the goods that are stored in a warehouse, they are always classified in high runners, medium runners, and low runners. And of course, the high runners are the closest to the traffic zone at the beginning. So what we basically do is that when our people are working in an aisle, we switch the lights on. But if they are not present in a certain section of an aisle, we will dim the lighting there. Why do we dim? Well, because we want to have people not to fear and not to look into a dark area. But once they left the complete aisle, then we will switch the lights off entirely. With a system like this, we can also follow changes in the layout very easily. Sometimes people remove racks and make additional areas for their value-added services. For instance, packaging, adding stuff to products, and in those areas they remove the aisles. Well, now it is possible in an area like that to group all the luminaires that belong to an area and switch them off and on simultaneously on occupancy, for instance. Another technology that we use is daylight-dependent ventilation. We have to use some special technique for that, because normally in an office we would look down at the floor, but in a warehouse that is not a good idea, because the floor at the beginning will be very shiny, and after half a year it will be full of rubber, meaning that the floor is not a very good indication of the light level. You can also not put a sensor on the floor. That would be very difficult to do. So what we do is we basically look at the sun. We can look at the amount of incoming daylight, and depending on the amount of incoming daylight, we dim the luminance accordingly. Most of the times we do that in 5 steps, and we do that with fading so that nobody sees that there's something happening there. We have a slow down, so that means that we very gradually slow down the lighting system. But if the sun is gone, we go fast up, because we want to ensure that there is always enough light available in the warehouse, so that people can do their work there with the right amount of light. I want to give the presentation now to Alan, who will go a little bit more into detail.
Thank you, Paul. So I've been listening carefully to what Paul's been saying, and from my side, because I'm the trainer, this is where I get to crack my cane a little bit and dig a little bit deeper into some of the principles of what Paul's been saying. I have a few topics which I'd like to cover. We're going to look at, we're going to repeat the message that we know lighting. I think we should do after 120 years. Bit of integrated solution talk. We're going to talk a bit about application and how years of knowledge works when you're talking about application and lighting. We're going to talk a bit about the simplicity of embedding this knowledge in our system, a little bit about the functionality, and then that's about it this afternoon. Looking at my watch, just after past. So let's move onwards. One box, one network, many solutions. Paul's kind of said this already. Here we have 2 examples of where a completely a network solution in a one box solution really is a great way of connecting up with the KNX network. On the left here we have the structured cable, which will handle our 1 to 10 volt or our DSI or our DALI, depending on what we need at the time. This makes it a very, very efficient solution for retro installations. But of course, on the right here, what's very, very easy to install and requires a minimum amount of wiring would be a completely integrated solution where your sensors, your wall switches, your intelligence, everything is mounted on one network. In this case, it's a well, we're KNX in, and we're out to our DALI network. A very efficient solution, but more on that later. Let's take one step back. Well, as far as we're concerned in lighting, switching lighting is not just about switching on and switching off or dimming. That's the old way of doing it. It's the KNX way of doing it, perhaps, where we simply go via controller, actuator, light on, light off. If that's what we did all the time, then we wouldn't be able to talk about dimming unoccupied areas. We wouldn't be able to talk about dimming the surrounding area or holding our corridor or step over patterns or cascading and all these wonderful things we like to talk about. In fact, let's not talk about switching. Let's talk about the state of being. Because of the lighting knowledge that we've gained over the past how many years, I won't say it again, we are interested in state. Any lighting effect that we create is about changing from one state to another. Here we have two very, very common examples. On the left, European traffic light, on the right, UK traffic light. These aren't just switches, these are pieces of information. If you see an orange light in the Netherlands, it means you should stop. If you see a red and an orange light in the UK, it means get ready to go, and so on. So these are states, and we do the same thing with our indoor lighting system. So by capturing different states or scenes and having our system pre-programmed, we can recall each one according to our needs at that time. So the key here is about pre-programming and using history and experience. This is the preferred method for lighting control. It offers superior logical functionality and, of course, reduces expensive programming time when you compare to basic switching. And scenes can be set up to allow simultaneous recall of different levels and multiple channels by a single telegram. There we go, we're already back in KNX speak. In this example, we have up to 16 different scenes, and as you can see from the wording, they are very easy to understand, application-based terms, and you can imagine the kind of effects that we might have built into these different applications. Let's take movement sensing as one example. Traditionally, we would expect a sensor to trigger an action upon movement, and after a period of time, just turn off again. Well, the best lighting solution is to pre-program this sensor to perform this task, but of course warn the users of the space before switch off. We call this the grace period. So within our software, we have the freedom to change parameters such as time settings, actual light level, but basically you have a pre-programmed setting which knows after a certain period of time it's time to warn the occupants. If you don't move, well, you better get out of the room. But of course, this is just a very, very simple example. And I mentioned earlier on, we're talking about scenes and presets. You don't necessarily have to turn off once you no longer sense motion. You could go into a different scene, maybe a position where you have this background safety lighting, a bit like Paul mentioned in the warehouse example. You might wish to have the reverse of this, where you walk into a room and there's a low level of lighting until it senses that you want to have your full level of lighting. This might be appropriate in certain industrial applications. And taking this one step further, I mentioned already, based on the knowledge that we've put into our lighting, we use our experience to build an interrelated flow of different behaviors which is easily adapted to suit the various lighting scenes in a project. In short, the hard work is done for the system designer and the commissioning engineer. So again, I've superimposed the previous example here. In case it's difficult to read, we start off with our lighting coming on, 15 minutes. If after 15 minutes it detects no movement, we have a switch off warning. This then continues until completely off state, until movement's detected once again, and the whole process starts again. On, warning, off, off, on again. Okay, so that's some basics. Now bear with me for the next few slides in case you haven't yet done your KNX basic course, and this really is the first dip of your toe in the water of KNX. Now, from KNX to the lighting world, here we have your ETS4 software as mentioned earlier on by Paul. If I want to access the device that I've been talking about, we would simply go into the plugin and we're already in our lighting world. It's as simple as that. So we're stepping from KNX into our lighting world to make any changes, to set up our parameters, and then we step back out into KNX world and everything will work on the KNX network. So the simple process would be you do your floor layout, you label up your rooms, you create your groups and group addresses. That's KNX speak, by the way, for those who haven't been there. And then the rest of the magic takes place in this dedicated actuator, which is loaded with lighting know-how. So it really requires the simplest amount of physical wiring than ever before, as everything is fitted onto the same network. I'll continue. We talk about application embedded scenes. Once again, please bear with me. What we're looking at is the same grace position scenario once again. What I've chosen here, I've highlighted, are motion actions and no motion actions. So each time we have a motion, we want to tell our lighting system to perform a function. And that's one of these scenes that I've mentioned. When we have a non-motion action, we want to perform another output. So let's just say our motion action will be telling the light to come on to 100%. Our no motion action will be either to fall to the grace position or with the pre-programmed delay to go to the off position until the next movement has been detected. So this is how it looks in the plugin. And similarly, we have the same story for our sensors. Again, you're looking at the plugin here. So all this embedded technology is sitting in the plugin, and we have a number of different application-based scenarios that are pre-programmed, and we just have to select the one that's appropriate to the kind of behavior that we're expecting. Now, you would expect everything to be editable. It is, but obviously, as you become more familiar with the plugin and you know what it is you need to tweak, for example, if you're using movement detection, you may wish to add some kind of daylight sensing, and you can combine these very, very easily. I hope you're all still with me. And finally, we've set up everything. We're back in World of KNX, and what I've just done here is just to remind us that, of course, we need to match all our objects with our group addresses in exactly the same way as any other KNX device on the network. So in fact, we're talking about KNX is really the motorway network of our lighting system, and all we're offering is a clever utility vehicle which is nice to drive and fits perfectly within the lane and behaves every time. So back to some of the functionality. Again, I'm thinking about this warehouse. So we have our aisles, we need to aim our sensors down at the aisles, and of course it makes no sense if one sensor cannot speak to the next one. So we simply apply a step-over pattern. This activates or can maintain this desired level in multiple areas adjacent where occupancy has been detected. So there's no delay, or worse still, no shadows as the forklifts drive up through the aisle. So this offers complete flexibility for setting up lighting behavior in corridors. I'm now talking about the wider internal space, offices, large open plan spaces, public areas, where these areas may overlap. So again, this can give a sense of security and well-being for the occupants. Likewise, the corridor hold-on, which you may have heard mentioned already. This makes the light level in one area dependent on the occupancy state in another. In other words, the corridor lighting in this example will remain on for as long as somebody occupies one of these spaces. And it's at this point I realise that I've been pointing my mouse at the screen, and I should have been using the nice red dot which you now see dancing in front of you. But okay, I think the point's clear. In this example, all the connected areas notify their occupancy state. This ensures that associated areas remain on until the last person leaves the building, and then finally the corridor will turn off. If we can then translate this into the warehouse area, and we see that the functionality is very, very similar indeed. Taking this one step further, we might like to use the same functionality to apply to an open space to maintain a level of background lighting. So we use a parent-child concept where the desks or the work islands, we call these the child, are linked to the larger space, which is the parent. The parent maintains a low-level presence whilst any of the islands are occupied. Well, it's a little bit like the parent watching the kids play football on the side and not wishing to show them off to their friends. So only after all the desks are vacated, a delay is applied before the final switch off, just like in the corridor example. And again, we can take this one step further. We can create a cascade scenario whereby the office talks to the corridor talks to the lobby talks to the car park. This is a bit like following the occupants out of the building until the final person has left the front door and gone to the car park and driven home. And only then does the lighting finally switch off. It may be off, it may be dimmed to a minimum, but this can all be programmed in. We're going back to basics. I mentioned we won't talk about switching, but of course, with the plugin, you may wish to combine simple functions such as switches combined with sensor. Having it auto off, this guarantees additional savings for those people who don't like to turn off lights when they leave the building. Let's talk about sunshine. It's been mentioned already by Paul. We can apply daylight harvesting with rows by the window. This can reduce the amount of artificial light recording and save energy. Again, I'm talking purely about straightforward offices where we have daylight rows, where we really want to enhance the bright light coming through. Okay, so you say we've heard of this before. Of course, we can dim lights down when the sun comes up, but we can do this a little bit more cleverly. But I'll come back to that in just a second. I want to mention the functionality that Paul mentioned for the warehouse about the bands. The way that we do this in our plugin is by using the scenes to create bands whereby your photocell detects different bands of light coming in. In this two-tier example, we simply have a band from 0 to 505 lux. So what will happen here is it will automatically recall scene 1, which is basically on. So 500 lux is our on. Now, between 505 and infinity, it will recall scene 4, which is off. Now, it's not really a practical example. And again, I'm thinking about the warehouse example with 5 bands, where you will want to have a kind of a staggered scenario, perhaps 0 to 200, 2 to 5, 5 to 750, etc. Particularly if your photocell is facing outside, you'll be measuring more than just 500 and 600 lux. So perhaps 65,000 is a bit more realistic. But I think you get the idea. The point here is that this is pre-programmed, and you can edit this according to your knowledge level as you become more confident with the plugin. And of course, before I move to the next slide, it doesn't have to be on and off. We've mentioned that scenes are what controls the space around us, and you may wish to switch when the light reaches a certain level. Maybe some kind of alarm takes place. That can also be programmed in. I mentioned row offsets, but about daylight regulation. Well, we take what is actually a more complex concept and we build in a very, very simple solution, again, because this is all pre-programmed in. So I mentioned areas adjacent to the windows receive more daylight and those closer to the core of the building. So what we do is we build in a sort of stage lighting level between the window and the core. So the window area luminaires are dimmed to a low level and the luminaires in the core or in the corridor area. And this is a predetermined percentage subject to a small adjustment. So this is a far more realistic scenario than maybe the solutions of 10, 15, 20 years ago, where the daylight row along the window would simply switch off. It would look very odd, and the inner part of the building would just remain bright, and we weren't really getting the kind of savings that we need. Well, I think I've touched on a few aspects that we can offer with our plugin. I hope that this opens your eyes a little bit to what can be done when you try to pack in years of experience. Obviously, the proof of the pudding is in the eating, and I invite you to read a bit further into the devices we offer by going to philips.com/KNX. And in the coming months, I'm sure you'll still be hearing more from us.
Thank you, Paul, and thank you Alan for that very, very informative and in-depth presentation. I'd like to remind you that we have 2 webinars coming up in June, on June 12th and on June 26th. A slide will be coming up with the information for those webinars soon. If you have any questions or think of any questions later on, please note that a LinkedIn community will be available and will pop up after you close this webinar session. So go ahead and join that LinkedIn community, post your questions there, and Paul and Alan and the rest of the professionals here will be able to help you out and answer some of the questions you might have for us. Again, don't forget to sign up for the June webinars, Lighting Innovation for the Ages on June 12th, presented by Tom Butters, and Virtual Natural Light for Healthy Work Environments on June 25th, presented by Evert van Loenen. Thank you, and again from Philips University, we're signing off.